Hello, we are going to discuss on the how do we make a PD model. PD model is probability of default. So how likely is the person to default if he has taken a loan? So here, this is how a technical document is prepared. So before we move on to the actual problem and the actual data, I thought I'll just share about how does this technical document get prepared. So initially there is this title page which includes the information. Then the goal is to predict the likelihood of loan default for individual borrowers to mitigate or to reduce the credit risk and improve the lending decisions. So here we have the data understanding, that is the dataset overview, which includes the source of the data. It will be the internal credit database and the external bureau data that we get. And here borrower demographics, the loan characteristics, whatever is the credit history, and the target variable are included. So credit history can be the FICO score, the delinquencies as in anything, any illegal activity done by the person. Loan characteristics, what is the loan amount, what is the interest rate, what is the term of the loan. All these are included, and I will also show an Excel sheet which we can create for the data dictionary. Initial insights, the univariate and the bivariate analysis can be done, which will give us some insight about the data, like the default rates are higher for lower income groups and borrowers with low FICO scores. Then data preparation, we can create new features also, like loan to income ratio, credit history length. All these new features can be created. We encode the categorical variables, we one-hot encode certain variables, and we make use of feature selection techniques. So for feature selection, we make use of information value, and then we make use of correlation and also VIF. Then we use standard scaler for all the numerical features. For splitting data, it's done in the ratio of 80:20, and modeling is then done. For modeling, logistic regression is the baseline model, decision trees, random forest, XGBoost, and neural networks can also be applied. Once we do this, we perform hyperparameter tuning using grid search or random search, and then regularization techniques can also be applied to prevent overfitting. We also analyze feature importance analysis using Sharp or Line. So this is a basic performer for a technical document. Let me also show you the data dictionary that we have. So this is the data dictionary, which indicates ID, the member ID, the loan amount. Now here funded amount is the same as this. These two columns are same, so this column gets dropped. Employee title has this is the type of the columns, indicating if it has null, what is the percentage of the null values, how were the null values getting treated, and what were done, what was the action that was applied. So here 6.2% values had null, and so this was indicated with a 0 or 1. If it was present, it was indicated as a 1, otherwise it was indicated as a 0. Employee length also had null, for which buckets were created. For home ownership, label encoding was done. For annual income, there was 0.002% nulls, which were filled using mean. And for description, 54.22% data was null, and so it was dropped. So now here for each and every column we list what was the treatment done for that particular column. This is very much needed in a real-time scenario where there are hundreds or 200 variables. So this had 84% null value, so it was dropped. Certain columns were maintained as it is. Certain columns were dropped. So depending upon that, this particular Excel sheet can be filled, where we list the details about each of the column. Let me demonstrate. So now we are going to look into the data. So this is an Excel data, and there are 86 columns in total. So now, because we are maintaining this particular data set had some 2 lakhs of records, but then for our purpose we are considering only 1000 records as of now, otherwise it takes a lot of time to run. So these were all the columns that we had. Application type had only individual as the record, and so it was deleted. So describing the data, we understand what is the 50%, 25%, the minimum value, and so on. So now we check which are the columns that have more than 50% data as null, and we drop those columns. We were dropping few other columns which were not found to be appropriate, like funded amount invoice. It was already there. Loan title was again present. DTI is again available. So as per GDPR, that is as per anonymous responses by people, we are not supposed to use their ID, member ID, gender, their location. All these cannot be used for training purposes, and so we remove these columns. So GDPR basically stands for General Data Protection Regulation, and here it aims to give individuals more control over their personal data. So any organization that processes personal data has to ensure lawfulness, fairness, and transparency. And we should collect information only that is required and keep data only as long as necessary. So this comes under GDPR. There were certain columns which showed no variability, like policy code, initial list status, and these other columns, and so these columns were also dropped. So there were certain columns which were dropped. Employee title, it was changed to 1 if it is not null, 0 if it was null. We also remove duplicate rows, and here employee length was categorized as if it is less than 1 year, 1 year or 2 years, it was categorized as 1. If it was 3 years, 3 or 4 or 5, it was put as 2. If it was 0, it was put as 0. If it were otherwise, it was just put as 3. Home ownership also one hot encoding was done for this. And now for purpose, there were various purposes that were there, like debt consolidation, credit card, other, home improvement, small business, car. So here anything that was less than 5% was just put in the category of others. So category values, wherever it was less than 5%, it was all just put as others. Then we checked for delinquency. So wherever delinquency for 2 years is more than the total accounts, that has been put as 0. If number of delinquency in 2 years, if it is more than total account, then it was replaced with 0. Moreover, we removed the term months from the term column, from the column which is called terms. Term indicates the loan term, and so we remove months so that we get the months alone, and for that we are doing one hot encoding. For loan status, this is our dependent variable, the Y variable. This is loan status, and this included fully paid, charged off, current, default, late, in grace period, and so for all these 0-1 mapping was done. Now there were certain columns which had values like inquiries in the last 6 months, inquiries in the last 12 months. Now if the inquiries in last 6 months, it's let's say some 5, then inquiries in the last 12 months has to be equal or more than 5, it cannot be less than 5. So here we were comparing these columns to check is there any mismatch in those kinds of data. If there was any kind of mismatch, then we were checking the mean, and if it was more than 5. So here for each and every column pair we are checking the number of times that it was more, and if that mean was found to be more than 5, we dropped those columns. Verification status had 3 unique values: verified, source verified, not verified, and here we mapped the values to 0, 1, 2, dropping all date columns because here the modeling is not dependent on any date column, and filling out the remaining all the data with null values with 0. And we also had is inquiry column. Now here is this particular column refers to whether is the income verified or not. So it was this, if it is not verified, 0, verified is 1, source verified is 2. Payment plan mapping, yes with a 1, no with a 0. Now we had some histograms to check the distribution of loan amounts. So this is the distribution of loan amounts that we get, and this is the corresponding box plot. We calculate the Z-score for annual income and loan amount. There were certain outliers. There were no outliers. There were certain outliers for annual income, not for loan amount. So wherever the outliers were seen, those were substituted by the capping method. That is, that 99% of the data was captured. We dropped the grade column because we already had the subgrade, and now for the subgrade we calculated the weight of evidence. The weight of evidence and information values are concepts which are used in credit risk modeling. The weight of evidence, it transforms whatever are the categorical continuous variables, and it captures the relationship between the independent variable and the target. And the IV indicates the overall predictive power of a feature. So here we calculate the WEE or WoE on subgrade. So this is the column which calculates. Moreover, here we calculate IV numeric. This is the function to calculate VIF, and this is the function to calculate correlation. This is our data which has 1000 null values. So first of all, we apply WoE transformation on the column. Whatever are the infinity values, those are replaced with nan, and we also replace nan with zeros. So here data.drop columns equal to categorical features. So here we are dropping all categorical features and retaining all the numerical variables. Here for the numerical variables, we further go ahead to calculate the IV values. The next step is to calculate all the numeric values, we calculate VIF. We make use of both Spearman correlation and Pearson correlation, and so we get the feature and their Pearson value. So here we get so these are the feature, the IV values, the VIF values, Spearman and the Pearson correlation. So these are all the values. Now here, depending upon, we give priority to IV should not be 0 and VIF has to be less than 5 only, and then we sort the values depending upon IV and VIF. So wherever the IV value is more, information value is more, because it shows me the predictive power of the particular variable. So here wherever the IV value is more and the VIF value, The next ordering is VIF value. So I am looking for IV to be higher and VIF to be lesser. So in here it has both infinity. So this has to be arranged here in the ascending order, and then whatever are the corresponding Spearman and the Pearson values, these are also taken into account. Now sometimes one important thing here is there may not be a linear relationship between the feature and the target variable, and so Spearman correlation is also being calculated here, and that is what helps us. So we take the top 20 features depending upon this, and so we retain only the top 18 features. Along with that, we have the risk score feature, which is very important, so we maintain that risk score feature, and we also transform our data using Yo-Johnson method. Yo-Johnson method helps us to transform the data when there are negative values also. After that, we scale the data, and then we also have one more variable. We make use of one more feature, that is the KNN similarity score. So depending upon all the values that are there, we calculate the KNN similarity score. That is a score which is considering the various records, and depending upon how similar are the records to each other, a KNN score is given to the records. A train test split is performed, after which we try to find features with any zero variance columns, but there are no columns like that. We fit the logistic regression model, and then once we fit the logistic regression model on this particular set of features, we calculate the KS score, we calculate Gini, then we calculate lift, and then we also calculate various other metrics like the threshold and precision, recall. We calculate all these various. Now KS statistics stands for Kolmogorov Smirnov. Now that value ranges between 0 to 1, and higher the value, better it is. It shows the cumulative distribution between the goods and the bads. Then there is the next is Gini coefficient. It shows the model's discrimination power. It is nothing but 2 into AUC minus 1. So it again the value lies between 0 to 1, and 1 is a better value. So higher the value, better it is. Lift tells how much better the model is at predicting positives versus random guessing. So lift more than 1 means the model is adding value. Then we have other metrics like accuracy, precision, recall, F1 score, AUC, ROC score. And here what we do is, this is the metric which is calculating all of these, and we calculate at various thresholds. See, these are the various thresholds. We are looking between 0.1 to 0.9. We are looking for 100 equally spaced values. So these are the various thresholds that we are considering. And then we are checking that what is the optimum, at what threshold am I getting the optimum value. So at 0.5 threshold, I'm getting these as the values: 0.67, 0.86, 0.75, and so on. So as you can see, so I have 100 threshold values, 100 equidistant threshold values: 0.100, 0.108, 0.116, 0.124, and so on. 100 equidistant values, and I am having precision, recall, F1, Breyer, KS, and Gini. So these are the values. Breyer score is nothing but, it shows the accuracy of probabilistic predictions, especially when we use it for binary classification. And lift. So these are the values, and final metrics shows that at the threshold of 0.86 6, we get the precision of 1, recall of 0.86. Now, how are we getting at what threshold? Now, these are the values for various thresholds. Now, what is the right threshold that I'm looking at? I am looking for the threshold where the F1 score is more than the KS score. So that becomes my so I take the maximum value of the KS and the maximum value of the F1 score, and I check what is the optimum threshold. Optimum threshold will be nothing but where this maximum value of F1 is more than the maximum value of the KS. So that becomes my optimum threshold. Here we have F1 as 0.92 and KS as 0.86. So 0.92 more than 0.86, and that is the threshold 0.85. See, here we have 0.40, 0.86 and so on. So here at this threshold, F1 is more than KS, and so that becomes my final metrics, final threshold that I'm looking at. So I get the intercept and also the coefficients, and so these are the various features and these are the relevant coefficient, which is going to give me the final PD model result. Now if I have to calculate log odds for each of the row, it will be nothing but the next step is scorecard creation. For scorecard creation, I take the process data and the coefficients, perform the dot product between the two, and add the intercept to it. So that will give me the log odds. So consider if I want to calculate the credit score for these, then in that case the PDO is 28.85, base score is 600. Now how do I get this? This is nothing but 20 by natural log of 2. So that is going to give me 20 is nothing but the points. By what point is it getting calculated? So credit score is calculated on the basis of base score plus the PDO into log of odds. PDO is the point to double the odds. Let me just explain this in detail. So consider if we capture the various features like the income level, credit history, age, existing debts, and the employment status, and then we calculate the coefficient for all features, indicating the impact that each feature has on the log odds, and then consider if age is 30 years and the income is 50 years, which is scaled to some values. We calculate the log odds like how we did just now. This is the intercept plus the dot product of the data and the intercepts, giving us a log odds value, and then we calculate the PD by 1 by 1 plus e to the power minus log of odds. So that will give us the PD value. To calculate the score, it's nothing but the base score plus the scaling factor into log of odds. So the base score is 600. The scaling factor is nothing but PDO by natural log of 2. PDO is nothing but how many points are needed to double the odds. So let's say if the odds half, that is from 20 it becomes 10, then the score will decrease by 20 points. If the odds double, that is it becomes from 20 to 40, then the score will increase by 20 points. And further, let's say if the odds double 40 to 80, again the points will score will increase by 20 points, so it will become 640 and so on. So the final calculation will be if PDO is 20, scaling factor will be 20 by natural log of 2, 28.85, and the final credit score will be the base score plus the scaling factor into log of odds. So that will give us 610.38. So using this log of odds, which is 0.36, I can either make use of calculating the PD model, or otherwise I can go ahead and calculate the credit score. So here the base score, which is 600 plus PDO 28.85 into the log of odds, and that gives me the credit score for all the data. This is the credit score for all that is the first 5 credit score for each and every person in the data. So this is how we prepare a scorecard creation after we prepare the PD model and perform the credit risk analysis.